I can assume that you have understood everything. Okay.
Sir, I have some questions.
Yes, tell me.
Sir, yesterday you've taught limitations of chemical equation. Under this, one point is that whether the reaction is reversible or irreversible. But sir, in chemical equation, we can a reversible reaction is represented by two half arrows, no, sir?
Yes, but what did I give you any two opposite arrows? We did
Sorry,
not
sir?
give. No? See, reversible reactions are always being given by two opposite arrows.
Yes, sir.
Okay, but in the equation which I have written, it was not there. So later on, many modifications are being done.
Okay, sir.
So that we'll learn when we go to thermodynamics. That we will learn when we go to equilibrium chapter. All right.
Okay, sir. Thank you, sir.
Then what are the other questions?
Online skit tomorrow. Down call kayo na video call ah.
Oh, what is the other question? This is the only question you had. Okay, then. So now we'll do. Today we'll do empirical formula and molecular formula. Molecular. So let us first know what is called empirical formula. It is the simplest formula based upon the percentage ratio of the elements present in a compound. See, all of us we know the formula of benzene is C6H. This is the you have learned. See, what is the ratio? 6:6. So if this is the molecular formula, is empirical formula is CH. All right. So it is based upon the percentage ratio of the elements present in a compound. So now what is molecular formula? It is the true formula. Formula of a compound having actual number of elements present in it. So, example I've given you right here now. C6H. What is this? This is benzene. Okay.
Pardon, sir.
C6H12O6. This is what? Glucose. Yes. Hello. Do you have any doubt? Now, what is the empirical formula here? Empirical formula of benzene is CH. See, in 6:6 means 1:1. What will be the empirical formula? See here, 6, 12 is a multiple of 6, and this is 6. What will be this? This will be CH2. Now, what is the relation between empirical, sorry, cal and molecular formula? See, if I multiply this by 6, I get this. If I multiply this by 6, I get this one. So we can write here molecular formula. N is the divisor. We divide by N. N into empirical formula. Now, how to find out the value of N? So for that, what you write? N is equal to empirical formula weight divided by molecular weight. So we'll do one problem, and I'll show you how to get it. Have you finished writing?
Yes, sir.
I told you, no, moment you finish, you tell me. In this process, in this way, the process becomes slow. So if I spend so much time in one unit, this unit is the smallest unit, then what will happen? Already we have started 2 months late. And numerically, if I do not do, you also will not do it. Okay. So numerical is mothballs. Have you seen mothballs?
No, sir.
Yes, all of you have seen. It is used in your house to protect your clothes, books, and everything from the insects. This is called We call it naphthalene. Contain 93.71% carbon and 6.29% hydrogen. If its molecular mass is 128 gram mole inverse, calculate its molecular formula. Have you done this one in school? In class 10, have you done?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. You're from which school? From which
Center.
board you have done?
ICSC.
Yes, in ICS it is there, but in EMBOS it is not there. CBSC also I doubtful whether it is there or not. Okay, so I will show you. First you have to write one table, and on the basis of that you will do it. So here we will write element. Then we will write here percent. Then we will write here atomic mass. Then we will write relative number of atoms. Then we will write here simplest ratio. Then we'll write here simple whole number ratio. This table you have to remember. Otherwise, this sum is very, very easy. Now try to hear me. Say here. What are the elements given? Carbon and hydrogen. So we'll write here carbon and hydrogen. Okay. What is the percentage of carbon given? 93.71. Hydrogen is 6.2. Atomic mass of carbon is 12. Hydrogen is 1. Now, dear, this I'm going to do the first one. After that, I will not do. See, this compound may contain carbon, hydrogen because you do not know. It may contain some other elements, especially oxygen. Oxygen they will don't give. So what we'll do? The moment it is given, you add it. Well, is it 100? If it is 100 or very near to 100, say it is 99 point something, no problem. But if you find these values are not equal to 100 and differ from 100 by 5, 6, 10, 12 like this, then please remember, add it and subtract from 100, rest will be oxygen. So this one you should know. Until unless you don't know, you do not. It will not be known to you.
Excuse me, sir. Sir, can you please repeat once again?
Yes, see here. See what are the elements given. All the elements will be given, but oxygen will not be given. Okay. This I'll discuss when I'll go to organic chemistry. So immediately add both of them. If it is 100, all right. And if it is very close to 100, say it is 98.9, 99.2, no problem. But if you find the difference is more, then please remember oxygen is present. So you add this to subtract from 100, this will be for oxygen. We'll do one problem. Now, relative number of atoms, no problem. 93.71 divided by 12. It is, you have to divide this one by atomic mass. 6.29, then divided by 1. Okay, so I'll write this one little close to this one. 93.71 divided by 12. I'll write the value here. 6.29 divided by 1. Obviously, it is 6.29. So what is, if I divide it, what do you get?
7.80.
No? 7 point? 7 point how much?
80.
Yes, good boy. 80. Then simplest ratio. Then out of these two figures, which is lower? This one. So you will divide this by this and this also by this. So 7.80 divided by 6.29 and 6.29 divided by 6.29. So this is 1. And this is equal to 1.24. See, we know atoms always combine in whole number ratio. It always combines in whole number ratio. So, but here you find is 1.24. Then in that case, we have to find a common multiple. If I multiply this one, then in that case, it will be a whole number. See, if I multiply 1.224 into by 2, what do I get? 2.48. If I multiply by 1.2, this is by trial and error method. If I multiply, what do I get here? 2, and this will be 2, and this will be 3. So this is also not whole number. If I multiply by 4, so this will be 6. Okay, this will be 6 and 8, 9 into this. That is 3.96 is almost equal to 4. So what I'll write now? This multiplication I need not show. I'll do it outside and I'll write here 3.96 and here it is. I have to multiply. If I multiply this, I have to multiply same thing with this one also. So it will be what? 4. It will be, I have multiplied this by 4 and this I have to multiply by 4, 1. So 3.96 I'll write. Okay, I'll write here 3. Not 5. It will be if I yes. If I multiply by 4, so it will be 16, 9, and this will be 4. Yes, so it will be 4.96 is equivalent to 5 because I have to make it whole number ratio. Understood now? It will be 4.96. So this is the way you have to do it. So what is your empirical formula? Thus, the empirical formula is equal to C5H4. But we are being asked to find out, calculate its molecular formula. So we'll write now. We'll write here molecular mass equal to N into empirical formula mass. Therefore, N is equal to molecular mass divided by empirical formula mass. So let us find out what is the empirical formula mass. Empirical formula mass of C5H4. So C5H4. So now you know 5 into 12, because atomic mass of carbon is 12, and 4 into 1. So how much it comes? 60
64.
is equal to 64. So now we'll write, therefore N is equal to what? N is molecular formula mass. Molecular mass is already given 128. It is 128 by 64 is equal to 2. So what is the molecular formula now? Molecular formula, I multiply this by this. So it will be 2 into C5H4. It is C10H.
Sir, can you repeat the question?
An organic compound on analysis gave the following percentage composition. An organic compound on analysis gave the following percentage composition. Put a colon. Carbon equal to 57.8%. Hydrogen equal to 3.6%. And the rest is oxygen. Full stop. The vapor density of the compound was found to be 83. Write the molecular formula of the compound. See, oxygen is also there. Its atomic mass is 16. So I told you, you have to add both of them. Then what about the total you will get? Subtract from 100, that is the value. Okay. So now I'm going to remove all of them and you try. Wherever you find difficulty, you tell me. I'll tell you, but I'll not write.
Sir,
Let others do. So now how much it is here? 57.8, 3.6. Oxygen ka no?
38.6.
38.6. Okay. So it is 57.8 divided by 12. 3.6 divided by 1. 38.6 divided by 60. Then this is equal to how much?
4.81.
4.8. How much did you get? 4.8. Then after that, what?
4.81.
So 4.82.
4.82. Girls are more careful of less. Then 38.6 divided by 16 kano. How much it comes?
2.41.
2.41. What is your name?
So Eileen.
Acha, good. Now see here. So we'll write now here 4.82, which is the smallest one. This is the, we'll write now 2.41. 3.6, 2.41. 2.41 divided by 2.41. Here this is 1 and this is 2. So 3.6 divided by 2.41 is how much?
So 1.49.
1.49. Sorry. Equal to 1.49 is 1.5 only. Now, with what should you multiply to get whole number? With what digit you should multiply? You to multiply all of them.
2.
So 2.
So two.
Yes. If you multiply this by 2, then you get here 4. 1.49 is almost 1.5 only. If you multiply, you get here 3 and this. So the empirical formula is how much?
Sir, C4 H3O3.
4H
H3.
4.
2.
So please find out empirical formula mass. You do it, I'll not do.
So 83.
Good. See here, do you find anywhere molecular mass is given?
No, sir.
Yes, it's not given. But dear, I told you, no. You remember the Avogadro's hypothesis? The Avogadro's law, what does it say? That molecular mass equal to 2 into vapor density. See here, what does it say? The vapor density of the compound was found to be how much?
83.
Good. So what is the molecular mass? 2 into 83 equal to what? 6.
166.
And it is 166. So now you know N is equal to what? You write down empirical molecular mass divided by empirical formula mass. Then you get the value of N, write down the molecular formula. These are not difficult, but only thing you have to do it little carefully, slowly and carefully.
Sir, done.
Sir, done.
Okay. So what is the molecular formula?
Sir,
C8H6.
C6O4.
What is the molecular formula? You tell me. C.
C8.
C8H6O4.
Yes. So now you know how to do.
Yes, sir.
Okay. So now I'll not write. I'll just tell you, please write down and do it. Right. A compound has anything which you don't understand, ask me again. A compound has 39.9% carbon. 39.9% carbon, comma, 6.69% hydrogen, 6.69% hydrogen, and rest is oxygen. Again, you check the digits. 39.9% carbon, 6.69% hydrogen, and rest is oxygen. Stop. Molecular mass of the compound is 60 gram mole inverse, G mol to the power -1 gram mole inverse. Stop. Calculate its molecular formula. So its molecular mass is 60 gram mole inverse. Calculate its molecular formula. I will not write anything. You do it.
They got it.
You've done it.
Yes, sir.
Then you don't tell. Let others do. formula?
Sir,
What is the molecular formula?
C2H4O2.
Okay, now all of you have done, or anyone who could not do it? Don't remain quiet.
Sir, empirical formula is C2H4O2.
Hmm?
Sir, empirical formula is C2H4O2.
Yes.
Okay, sir.
And molecular formula?
Sir, doing, sir.
Okay, do.
The molecular formula is C2H4O2.
And empirical formula is
The
C
CH2O.
H C
CH2O.
H2O.
Pardon, sir?
What is the molecular formula? Molecular formula is C2H4O2. Okay, now we'll go for stoichiometric calculation. Stoichiometric calculation. What is stoichiometry? Means ratio. So for that, you should be able to write balanced chemical equation, because we know chemical compounds are always formed by the stoichiometric ratio. So I'll do one problem for you. How many grams and volume of carbon dioxide produced when 4.6 gram of sodium carbonate reacts with excess of HCl. This is not difficult. Atomic mass of sodium is 23.0 gram mole inverse. Chlorine is 35.5 gram mole inverse. So first we'll write the equation. Sodium carbonate, HCl gives us NaCl, H2O, carbon dioxide. So I have to balance. 2 sodium, here I have 1. Okay, there are 2 hydrogen, I have 1. So I'll write it 2. I'll write it 2. See here. So it is balanced. 2 sodium, 2 sodium. 1 carbon, 1 carbon. 3 oxygen, 2 plus 1, 3. 2 chloride, 2 into 1. So it's 2 chloride. So it is balanced. Okay, now what is this mass? What is the mass of this one? So mass of this one is 2 into 23, sorry, 23 plus 12 plus 3 oxygen 3 into 16. How much it come? 46, 12 plus 64. So how much it will come now?
106.
106 gram. So I'll write now here 106 gram. Mole inverse is only know that. Okay. HCl is how much? See, 1 plus 35.5 equal to 36.5. So 2 into 36.5. It comes to how much? 70. 73 gram. Oh. So sodium chloride is not asked, so we will not bother for this. Water is also not bothered. We'll write now here carbon dioxide. It is 12 plus 32 is 44. Okay, so once you know molecular mass is equal to 1 mole, it is 1 mole. This is also 1 mole. So see, 106 gram gives you 44 gram. So right now 106 gram of sodium carbonate produce 44 gram of carbon dioxide. So 1 will be how much? 44 divided by 106. So 4.6 is how much? So 44 into 4.6 divided by 106. So find out.
So 1.90.
So 1.90. 1.90 gram. So this is the answer of first one. Done. Then what does it say? Volume. See, 44 gram of carbon dioxide is equal to 1 mole of carbon dioxide. Equal to what? 22.4 liter at NTP. So what you write now? 44 gram of carbon dioxide occupies 22.4 liter at NTP. So similarly, find out this will occupy how much?
So 9.03 liter.
How much?
9.03 liter.
9.0.
3 liter.
I think you have made some mistake again, you see. I don't know, but what I feel it. It will be 22.4 divided by 44 into 1.90. How much it comes? Check.
So 0.97.
Ah, see. Okay, let me again check. Where is the calculator? $22.4 into 1.90 divided by
0.96.
0.967. So you can round up, you can write 0.97. It is 0.97. Okay, 0.96. So you have to be a little bit careful. Now I am to tell you about the rounding up. You should know. You know that if it is 5 or more than 5, then you are supposed to add 1. There, the rule is there. To number to which you want to add. So you want to find that result up to second decimal. So 0.96, then 7 is more than 5. So you are supposed to add. No. To number to which you are supposed to add, if it is even, then you will not add. And if it is odd, then you will add. So 0.967, result will be 0.96. But if the result would have been 0.957, 5 is odd, then you should have added 1, 0.9. So understood now? Okay. Now. How much potassium chlorate should be heated to obtain 11.2 liter of oxygen? So I'll write down now here. KClO3, if you heat it, you will get here potassium chloride and oxygen. So let me balance it. See here you have 3 and here you have 2. Always go for cross multiplication. I'll multiply the whole thing by 3 and this I'll multiply by 3. See here. 2 KCl, 3 O2. Balanced. Heat and trial method, but you will take little time because I have been with these balancing chemical equations. 1973 to 2021. How many years? How many years? Any idea? 83, 10, 93, 20, 2003, 30, 2013, 40. So, how much? How many years?
43.
No idea.
40.
Huh?
43.
Honey, 2003, subtract
48.
2021 from 2003. How much it comes?
48.
48 years. So, you don't like chemistry, but I am with chemistry for 48 years. Okay. So, here I should write potassium is 39. And chlorine, you know, is how much? 35.5. And oxygen is what? 16. So, please find out. Write the mass of all these things. This is not required. Right? Find for this, find for this. Only I can write here, it is 2 mole. See, 2. How much it is? 3 mole. So please find out the molecular mass. In your exam, you have to do it, na? What is the mass of potassium chlorate? Huh? Do it. See here. It is 2 into 39 plus 35.5 plus 3 into 16. 2 I have written, na? 2. So how much it comes?
So is it 245?
I do not know. You only tell. Is it 245?
Yes, sir, I got like that.
Okay, then good. 245 gram. See here. Oxygen is 16. What is the molecular mass of oxygen? 32. So 32 into 3 can now. 96, no?
Yes, sir.
96 gram. See here. 1 mole of oxygen equal to, you will occupy how many liters of liters? 22.4 liter. 3 mole will occupy how much? Okay, see here. Huh? 1 mole or 32 gram of oxygen produce 22.4 liter. Okay. Therefore, what? 3 mole or 96 gram will contain how much here? It will be 22.4 divided by 32 into 96. So how much it comes? 67.2 liter or not?
So how did you get 32 gram?
What is the molecular mass? See, I told you molecular mass of a substance is equal to 1 mole. And 1 mole will occupy always any gas, 22.4 liter. See? Because of that, it is now I've written 3 mole. Molecular mass, when we express in gram, that is 1 mole. And 1 mole will occupy 22.4 liter. Because of that, I've written 1 mole or 32 gram of oxygen produce 22.4 liter. 3 mole or 96 will give you how much? See here, if I divide, suppose you forget, if I divide, is it not 3 mole? So it will be 67.2 liter. See now, I'll write now. 67.2 liter of oxygen is produced by how much? 245 or not? 200 and this is a simple unitary method. 245 gram of KClO3. Then 11.2 will be produced by how much? Don't get scared.
So 40.83.
How much?
40.83.
Yes. Now I'll give you one homework. Calculate the amount of lime, calcium oxide, that can be prepared by heating 200 gram of limestone. What is limestone? Is calcium carbonate, which has 95% purity. I'll write the equation for you. Okay. Atomic mass of calcium is 40 gram mole inverse. See here, calcium carbonate, if you heat it, this is a symbol of it. You get here calcium oxide and carbon dioxide. So this is your homework. So you do it. So next Tuesday you tell me.
Sir, excuse me,
Yes.
sir.
Yes.
Sir, I just want to say that I'll be starting my exams on September, and I'm really having a problem on chemical bonding chapter. Can you please help me with that chapter? It's really hard.
Tomorrow, what time your school starts?
We start from 9 to 1.